In this video I'm looking at the solution to question 4 of the June 2010 Edexcel M1 paper. The topic of the question is moments. So the question says that a beam of length 6 meters and weight 200 newtons is called AB. The beam rests in a horizontal position on two supports at C and D, where the distances AC and DB are both equal to 1 meter. Two children, Sophie and Tom, each of weight 500 newtons, stand on the beam, with Sophie standing twice as far from the end B as Tom. The beam remains horizontal and in equilibrium, and the magnitude of the reaction at D is 3 times the magnitude of the reaction at C. By modelling the beam as a uniform rod and the two children as particles, we need to find how far Tom is standing from the end B. Well, starting by putting this information onto a diagram, I've drawn in the beam. We're told that AC is 1 meter and also DB is 1 meter. We're also told that we have Sophie, who is somewhere on the beam here. Let's put her at this position. But in particular, we're told that the distance that Sophie stands from the end B is twice as far as Tom. So let's mark Tom in at this position, where the distances are x for Tom and then another value of x for Sophie. Both the children have weight 500 newtons, so let's mark in 500. And the weight of the beam itself is 200 newtons. There are reactions on the supports. We're told that the reaction at D is 3 times the magnitude of the reaction at C. So let's call the reaction at C R and the reaction at D 3R. Well, we can take moments about any point we like. However, as we're looking for the distance x of the where Tom stands compared to B, then it makes sense to take moments about B. So taking moments about B, and I'm going to take the values on the left hand side as being the clockwise moments. So looking at that for B, we have clockwise the reactions, which are a total of 5 meters from C. The length of the beam was 6 meters, so from BC it's 5 meters. Therefore we've got 5 multiplied by R, and then a total of 1 meter for the reaction at D, so this is then plus 3R. That's the clockwise moments, and on the other side I'm going to look at the anti-clockwise moments about point B. And now we've got the 3 weights, the weight of the children and the weight of the beam itself. So taking Sophie first of all, that is 500 multiplied by 2x. We've then got the mass of the mass of the beam, and so its weight 200 multiplied by the distance of that from B. Well, it's a uniform beam of length 6 meters, so that the distance of the center of mass is 3 meters. And then finally we've got Tom, who's 500 multiplied by x. So just working this out, or rearranging it a little bit and simplifying it, that's 8r on the left hand side, 1500 x plus 600 on the left hand side. So there's one equation. Now we've got two unknowns here. We've got r is an unknown and x is an unknown. So the other thing that we can look at are the total forces. I'm just going to equate the forces in upward direction. So looking at that, upwards we've got 4r, and on the other side of the equation, looking at the forces which are acting downwards, there's a total of 500 and 500 plus 200, so a total of 1200. Well, from this second equation, we can see that multiplying by 2, that gives 8r is equal to 2400. The first equation that we had 8r in it, therefore I can substitute. So substituting into equation 1 gives 2400 is equal to 1500 x plus 600. If you evaluate that then by subtracting 600 from both sides and then dividing by 1500, we get 18 divided by 15, or x is equal to 1.2 meters. Well, the mark allocation here, a total of 7 marks. Those method mark and 2 A marks for doing the moments equation, and then a method mark and an A mark for the equating the forces, and then finally method mark and A mark for finding the value of x to be 1.2. Well, that concludes the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.